Does it really work? It works, fine, right? Okay, so yeah, I'm Ilya, and today I'll talk about Swift string interpolation, which is actually not just a Swift 5 feature. That's why it's just 5, like up there. So yeah, let's start. So strings are everywhere, right? We use them every day, and in Swift, strings are a very powerful type. Maybe more powerful than in most of other languages. And one of the features that it had from the beginning was string interpolation. So what it allows us to do is it allows us to embed directly into string literal any string expression. It can evaluate to any type, even void. You can put just a normal string. You can put a value of any type, integers, closures even, optionals, your own types, and so on. But that's probably you're all familiar with, and there's nothing fancy about it and exciting. But let's look today under the hood how it exactly works and what changes with the new Swift version. So basically for this, there is a special standard protocol in the standard library called, very long name as always, expressible by string interpolation. Actually, this type was deprecated in Swift 3, and now you will not even see these requirements in the Xcode in the generated interface, but in Swift.org we can find a cached value, cached documentation for Swift 3 version, and there we can find this description. So one of the requirements, one of the requirements of this protocol is that you need to implement, your type needs to implement constructor inits with string interpolation that accepts self. This is an interesting detail. And then there is another constructor which is generic over its parameter, and it's called init with string interpolation segment. And also in these docs we can find actually description of the whole process of interpolating the string. So it says that the string literal, first thing, the string literal is broken into pieces. Each segment of the string literal before, between, and after any included expression in this bracket, along with the individual expressions themselves, they are passed to inits with string interpolation segment constructor. And as a second stage, the result of these calls are passed to the string interpolation initializer in the order in which they appear in the string, so they accept array. And that's why it's like a self with this variadic argument. So basically, from this description, we can realize that string interpolation is just a syntactic sugar, and compiler for us, at compile time, it will convert, for example, this simple expression hello/name, it will convert it to the code that will look kind of like this. And if we go inside and try to go step by step, then what will happen is that first it will get the first string segment, hello with space, create a string with this segment, then it will create another string with the value of our interpolated variable, and then it will create another string with the last segment, which is also a literal, and then it will pass all of them as array into this string interpolation, string with string interpolation method to construct the final string. Yeah. So cool. Pretty simple stuff, but what do we do with this? Well, the interesting thing that we can make our own types conform to this protocol, and that's the most interesting thing about this protocol. So let's imagine such thing that we want to develop. So let's say we have a blog, and like of course we can write a blog in Swift because we can, like I mean a backend and frontend. But what if we want to write our blog post itself in Swift, in Swift code? Like of course it's not possible right away because Swift is not a markup language and browsers don't understand it. But what if we use some other formats that browsers can understand, for example, Markdown or HTML. So this we can do, and let's imagine that we want something like this. We want some special type called markup. We want to write something in Swift, and then we want to be able to convert this Swift code to Markdown format or to HTML format. So let's look now how string interpolation can help us to do this. Like, I hope Xcode will launch normally. Actually, I have it open somewhere. Just need to make sure that it's recording. Yeah, I'll probably stop the presentation and we'll move this. Yeah. So yeah, don't pay attention to these error messages. It's just because I have two snapshots. Actually, I need to change to Swift 4 because now we'll look at how it works in Swift 4. So we'll start with defining our struct markup and conforming it to protocol. So we define the init with string interpolation segment, which is generic over its parameter, and we define another constructor, which is init string interpolation, which accepts array of self, and we pass it some value. For now, it doesn't do anything special. We just interpolate string into the whole string. But let's look what it will output, and we print result of the parameters of each constructor. So here in output, you will see that first it passes empty string to the init with string interpolation segment constructor. Then it passes first interpolated variable. Then it passes the next string segment, then another variable, then next string segment, and finally another variable. And then it passes the array of all these markup objects created for each segment as array to another, the second constructor. But of course, this is not useful at all, so let's extend this implementation. So because we want to be able to convert our Swift code into Markdown or HTML, we need some way of preserving the semantics of our elements. Like, for example, from the beginning, to start, we will just support 3 simple elements, actually 4. Just regular literals, then something that is like header element, italic, and bold strings. So for that, we can define like a type, like inner type element, which is just plain enum with associated value. So for example, h1 with associated value string, it will mean that this is the title that will need to be wrapped either in h1 tag or have a hash, single hash before it for Markdown. The same with italic and bold. Like, I'll not go into details of Markdown, how to convert it to Markdown, because it's pretty trivial. Then we need some way to accumulate all these segments. So for this, we will use this private parts array of elements. And we also need to save element for each segment, which is also like represented by this markup type, because you remember that it creates array of self. So in this generic constructor, the only thing that we can do basically is just to save this expression that was passed into interpolation segment variable. Parts will be empty. And then like this constructor will be called for each segment. And then finally we will get array of markup. And here we can go enumerate through all these strings that we receive. And here we need to do a small trick, because we don't know what is this markup. It might be just a string, like this interpolation segment, because we had to erase the type. So it might be just a string, then we create a literal. Or it might be an element, and then we just return an element. And this way we accumulate this part. And here, now we can write like our blog post markup. We can actually write it using this element. So we make a header, then we make something italic, and then we make something bold. And then let's run this. Yeah, and so as you can see, in the end, we get a markup object with all the parts. And first part is just a literal, then it's h1, then it's another literal, then italic, another literal, bold, and finally another literal. So with this, we can actually do some useful stuff. We can go through these parts and convert them either to Markdown or HTML. So we kind of achieved our goal, but our interface is kind of crappy. Like we have to specify the whole type, because if we try to do it like this, remove this, Swift compiler will be confused because it doesn't know on what namespace we try to call this h1, because this constructor that it will call is just generic. It's not constrained over the type of this t. So it just doesn't know what to do. And that's like kind of a problem. So let's see if we can improve this. So we can basically move enum a bit higher up in our types and make a markup enum itself, because we can accumulate elements in some special case of this markup, and we can accumulate each element like separately, also in a special case. And then basically the code is almost the same. We don't have this separate enum for elements. When we iterate over strings, we again like check for if it's a string or if it's a markup, and then we just use this value. The generic constructor is even simpler. We just create self with a special case of like this interpolation. And this allows us to remove this intermediate element type. And basically the result is almost the same. It's just we don't have this inner element type. But again, like this is also like it's better, but still bad. So the final iteration, can we do something with this? Well, actually we can if we define some free functions, which will hide all these details of accessing inner type. So we go back to our initial implementation with inner element type, and we just define free functions for each type of element. And this way we can just call them here, and this API looks much nicer than any previous our attempts. And the result is exactly the same. So that's the end of the first demo. Let's go back to the presentation. I hope it's recording all fine. So we saw that, yeah, string interpolation allows us to achieve what we want. But this design, the current design, Swift 4 version of this design has some limitations. First of all, it doesn't allow extra parameters in this generic init argument. It's just one argument. It can accept any type of values. It's not constrained. So because of that, we lose segment semantics. So then we need to check for the type later, which is kind of lame. And also it can have some memory overhead. And in the proposal for like revamping this protocol, this design, you can find a bit more details. Here's the link. You can go there later. So I will not go through details of these things. Also, our own design, the best version that we could achieve, is also not ideal, because we had to define free functions for each of the elements of the markup, which is kind of hard to extend, and it's just additional boilerplate. Also function calls, they add extra brackets, which is just a noise in the code. And these free functions, they pollute the global namespace because they're just global free functions. So you'll see them in the code completion. But at the same time, this design is already pretty powerful, and we could even, with free functions, we could even work around this limitation of not being able to pass several arguments to this interpolation, because we just have our own functions in the front. And people over time, they come up with much more useful and interesting use cases, much more useful for us as iOS developers. For example, for localization. So for example, here, you just need to define the string with the interpolated value, and then under the hood, this special type, localizable string, it will unwrap all of this and convert this string call, basically. It will convert it to call to an localized string to get the key, and then it will automatically append all the arguments that you passed as interpolated values, which is much more readable and nice than doing all this in line in your code. Or you can introduce some formatting for the same purpose. But as I said, this expressible by string interpolation protocol was deprecated in Swift 3, and actually it was promised in the docs that it will be rewritten in Swift 4. It didn't happen, but now in Swift 5 it finally happens. So let's see what changes. So first of all, the protocol expressible by string interpolation, it changes a bit. Now instead of aggregating these segments into the type itself, we have a associated type, which needs to implement new protocol string interpolation protocol. And then it has just one constructor that accepts just single parameter value of this string interpolation associated type. Let's look at this new protocol. So it requires you to implement a new initializer with two arguments. First argument will be the length of all literals in your string, all combined, if I understand correctly. And then interpolation count is a number of interpolated variables. So you can use this to pre-allocate space in your storage to where you will put all your interpolation segments. Then it has one required method, which is append literal, which accepts a string literal type. This will be called to append any string segments, literal segments. And then there is not like strict requirement to implement append interpolation methods. So let's, and this is the main new thing that happens with this protocol. So these append interpolation methods, you can have as many as you want. They can have whatever signature you want. They can accept as many parameters as you want, named, unnamed. They can even have default values. These methods can throw. The only requirement is that there should be at least one method like this that doesn't return any value or use discardable result, is annotated with discardable result. And when you call these methods, like you can't use trailing closures, though you can use closures as arguments of this method, of these methods. And you can use generics, like pretty much everything that you can do with functions in Swift. And what will happen in compile time is that compiler will limit what you can interpolate for this type based on these methods that you define. And it will warn you very nicely if you use the wrong type. For example, if your requirement is that you can pass only codable types inside this interpolation method, then it will not allow you to pass not codable stuff. Or if you make a typo. And also the generated code changes a bit. Instead of generating something like this, it will generate now something that looks like this. And if we go step by step, then first we create this intermediate string interpolation value with some parameters. Then we append first literal, then we append value, then we append last literal, and then we send the result to the string to create a final value. So finally, the last demo, I promise. Let's see how our implementation changes in Swift 5. So here I have Swift 5 version of the playground. I probably will not go through, like I have the same iterations. Like we start with just defining the protocol requirements. We can run it, we'll see that basically it's the order of calling and passing values is almost the same. The only thing that changes is that we create this value of associated type and then the final value. Then here basically the same design. We use element as inner type, and when we implement this interpolation type that serves as this aggregator, here we can pre-allocate some space to save our elements, and then we basically just append literals in each implementation of append interpolation. But the interesting thing here is that we have these three methods that defined on this type. So we will only allow to interpolate type of element and type of string. We will not be able to pass anything else. And this already allows us to, like, compiler knows that it can accept only string or element, so we can figure out the namespace, and you can just use .h1 or .italic, like if you used it with enum type, so it can interfere these types. And you can see that the result is like basically the same what we got before. There are some more improvements that we can do to this design. We can, for example, just forget about this markup type and just implement markdown right away. And here we will not need any enum, which is good. And we can just convert any value that we accept into the markdown and apply markdown syntax to it. And from the calling side, it will look a bit different. We'll just use named arguments to distinguish these interpolation methods, which is also nice. And finally, we don't even need all of this because we can just extend default string interpolation, which is a standard library type that string uses for interpolation. And basically, we can do the same as we did with markdown, just with basically, how many? 15 lines of code. Okay, let's go back to the presentation. Yeah, so we see that this new design is like, it's not a lot of very different from initial design, but it allows us to simplify our APIs based on string interpolation, and it allows us to simplify things that we could already do. For example, using booleans inside interpolation, we can just write a small if method that will use default argument for us. So we only need to pass one argument and not use question mark and colons. Or we can even write our own DSLs, which is a very powerful thing. So we can write DSL for string formatting and define what format for the numbers we want to use, or in what how we should format the numbers, like if it should be binary or whatever else. Or we can write attributed strings DSL, which is even more powerful compared with the NS attributed strings ugly APIs. So everything is inlined in one string, and you will even have some compiler support for that if you mistype something. Or we can use a very special, like implement very special cases like GitHub Markdown DSL, where we can define like helpers for issues, like or users or pull requests, which will be replaced with a specific Markdown syntax in runtime. Or we can even go a bit further. We can define our own template DSL, and then we don't need any template languages like Stencil or like Vapor templating languages. Basically, Swift is your templating engine. You just need several helper methods, and you're good to go. Or the most exciting thing for me personally is you can write kind of type-safe string formatting. So, for example, you can define a format that will accept some string parameter and some date parameter, and then you will at compile time you will only be able to pass the string type and date as parameters. You cannot basically screw up and have a crash in runtime when you pass a string instead of integer or something like that. Like this is pretty cool stuff, and like maybe it requires some separate talk. I don't think I have time to go into details, but it's very exciting stuff. And actually, there is one more thing. That's the last thing. It's not directly related to string interpolation, but it's related to strings. So before, in Swift 4, for example, if you write regular expressions, you can end up with hell of escaping slashes, or like here, you have to escape your quotation marks. Now with Swift 5, you can put a hash symbol before your string, any number of hash symbols, and then you don't need to escape your literals. Instead, you need to escape, for example, interpolation with the same number of hashes, like in between slash and open brackets. So this looks much nicer than initial version, and especially useful for regular expressions. Yeah, and that's basically it. Yeah. Do we have time for questions?